So you see what is happening. So we have in general, अगर हमारे पास कोई भी point हो x and y, right? So say suppose in the Cartesian coordinates, the coordinates of that point P is xy, and we have already seen in your lower classes that these coordinates of x and y, they can be basically shifted into another system, right? So we can have the coordinates r theta, right? So these are known as polar coordinates. So here x और y system को हमने r theta system में change कर दिया. So basically here x is r cos theta and here y is r sin theta. और अगर आप दोनों को add कर दो तो x square plus y square is nothing but r square. So r is under root of x square plus y square, right? And दूसरा अगर हम इसको divide कर दें तो what you get, theta is equal to tan inverse y by x, right? So we get theta is equal to tan inverse y by x, right? Just, am I audible? So we have these Cartesian coordinates x y. हम उस x y को किसी और system में change कर सकते हैं. For instance, आपने polar coordinates देखे हैं. So polar coordinate says x is equal to r cos theta, and then we have seen y is equal to r sin theta, right? So here, if you square and add, we get r is equal to x square plus y square का under root, and theta is tan inverse y by x, right? Similarly, in 3D, we have seen spherical coordinates, we have seen cylindrical coordinates, right? So basically, all these equations, they can be converted from one form onto another form, right? So we have these equations which are basically converted from one form to another form, right? And for this conversion, basically, if you remember, जब आप integration में change करते थे, right? अगर आप integration में change करते थे limits को, जैसे dx dy को आप dr d theta में change करते थे, तो आप साथ में Jacobian से multiply करते थे. So Jacobian is nothing but, this is nothing but Jacobian of xy with respect to r and theta. So you see, this is nothing but the determinant del x by del r, del x by del theta, right? Del y by del r, del y by del theta. So basically, if this Jacobian, if the value of this Jacobian is non-zero, then you can change the Cartesian coordinates into polar coordinates. Similarly, you can change the Cartesian coordinates into spherical coordinates and spherical coordinates into polar coordinates, right? So all these conversions are possible, right? So we have seen in your simple Cartesian system that you can change one system into another. Similarly here, in general, you see these x-axis, y-axis, z-axis, they are nothing but x's. They're nothing but directions, right? So one particular direction along the horizontal, right? अगर मैं आपको बोलूं real life में, तो real life में horizontal के along जो direction है हम उसको x-axis बोल देते हैं, और vertical के along जो direction है उसको z-axis बोल देते हैं, and breadth के width के along जो direction है उसको हम what do you call it as y-axis बोल देते हैं. So this is one particular system, right? In general, अगर हमारे पास कोई और पॉसिबल डायरेक्शंस हैं, देन हम इस सिस्टम को उस सिस्टम में चेंज कर सकते हैं, राइट? सो वी कैन ट्रांसफॉर्म XYZ coordinates into any directions provided they satisfy those conditions, right? So that is the reason this chapter is known as curvilinear coordinates, right? So coordinates of a particular point along any curve, right? So suppose I have a point P, right, and whose Cartesian coordinates are XYZ, then what I can do, right, I can express X as some function phi psi1 of some new coordinates u1, u2, u3. Similarly, I can express y as some function of new system u1, u2, u3, and z as some function of again the same coordinates u1, u2, u3. Obviously, all these coordinates u1, u2, u3, they should be independent of each other. They should not be dependent on each other. They should be differentiable. They should be continuous, right? Because continuity and and differentiability is something which we always want from a system, ideal system. Again, as I mentioned, the Jacobian, they're Jacobian. So Jacobian of transformation, right? So this is nothing but what? This is the partial derivative of x with respect to u1, partial derivative of x with respect to u2, partial derivative of x with respect to u3. Similarly, partial derivative of y with respect to u1, partial derivative of y with respect to u2, partial derivative of y with respect to u3. So this is u3. Then partial derivative of z with respect to u1, partial derivative of z with respect to u2, partial derivative of z with respect to u3. These three, this determinant should not be equal to 0. So this determinant should not be equal to 0. So कुछ books में आप देखोगे del x by del u1, del x by del u2, del x by del u3 वो नीचे लिखा होता है column में. So that won't matter because determinant of A and determinant of A transpose, they are both the same. So if this is there, if the Jacobian is non-zero, तो आप u1 को लिख सकते हो in terms of x, y, z, u2 को आप लिख सकते हो in terms of x, y, z and u3 को हम लिख सकते हैं in terms of x, y, z. Is it clear बच्चे? So this set u1, u2, u3 जो हमें मिला है, these are known as curvilinear coordinates of point P. And ये जो relation है, this relationship, right? This relationship which is changing u1 in terms of x, y, z and this relationship which is changing u1, u2, u3 in terms of x, y, z, right? They are known as transformation of the coordinates. Is it fine, बच्चे? Clear है सबको? बेटा clear है सबको?
Yes, ma'am.
Right. So now we will see. So I'm going very slowly. कोई भी doubt होगा, you can ask me in between. थोड़ा सा ये typical है, right? कोई भी कहीं भी geometrically कुछ भी doubt है, you can ask me. So now if you see, जैसे हम coordinate system की बात करते हैं, हमारे दिमाग में यही चीज आती है that the system, the three axes should be perpendicular to each other. Right? अगर हम कोई और भी system लेते हैं, so if I transform or rotation कर दूं, then also the system should be perpendicular to each other, right? So that system, ये जो हम XYZ system use करते हैं, इसको हम orthogonal system बोलते हैं. So in particular, अगर ये जो curvilinear coordinates हमें मिले हैं, so they are orthogonal. So basically they are known as orthogonal curvilinear coordinates. तो अगर मैं इसको geometrically देखने की कोशिश करूं, if I try to see this geometrically, तो before that let us try to understand the Cartesian coordinates. हमें पता है ये x-axis है, this is y-axis. And this is my z-axis. And if you see, जो ये है x और z के बीच वाला एरिया, इसको हम बोल देते हैं xz plane. And on this plane y is 0. On this plane y is 0. Similarly, this is xy plane, and on this plane z is 0. And similarly on the other plane, yz plane, x is 0. See beta, please understand one thing very carefully. जरूरी नहीं है कि y is 0. Actually y 0 is one particular system. Actually what I can say in a more what you call it as in a more mature way, that on xz plane y is constant. Y is constant. Obviously यहाँ पे आप y की 0 वैल्यू दे देते हो, so y becomes 0. But otherwise अगर मैं y को constant भी ले लूं, then also you go back to xz plane. Is it yes or no?
Yes, ma'am.
Actually yz is on yz plane, on xz plane y is constant, on xy plane z is constant, right? So basically ये तो अपने origin पे plane बना दी, इसलिए ऐसे है. Otherwise अगर मेरी ये simple coordinate system है, अगर मैं ये plane की बात करूं, you know, if I talk about this plane, if I talk about this plane, ये वाली plane, so you see this plane is nothing but my xy plane. And इस plane को मैंने बनाया है at some point z is equal to c. So you see at this plane my z is constant, z is c. So z is equal to c is also an xy plane. So actually we should not say y is 0. We should mathematically say y is constant. On xy plane z is constant. And there is one more observation. If you see, when xz plane and xy plane they intersect. So when xz plane and xy plane intersect, we get x-axis. We get x-axis. So on x-axis, y is 0 and z is 0. Is it fine, bache, all of you?
Yes, ma'am.
Right. अब इसी चीज को अगर आप in terms of 2D में बात करो, so here if you see, अगर आप xz plane में, अगर आप xz plane में, अगर आप let me just rub this one. I'm focusing on one plane because बाकी planes में तो you can very well code. So suppose I'm in XZ plane. अब अगर now I'm in a plane, so obviously plane में अगर आप कोई भी curve draw करोगे, so that curve will be a surface. So when I'm saying surface, surface means that curve will have some area. So that curve will have some area because we're in 2D. So 2D may we will always get a surface, right? So similarly here, so if you have three coordinates x, so if you have three curvilinear points u1, u2, u3, और अगर आप उसको plot करने की कोशिश करो, so if you see this is, so they may not, so there are any general curves, so three curves. So with red pen I have highlighted. So you see this is U2 curve, this is U1 curve, this is U3 curve. So in curves के बीच में जो area है, so if you see this is the area between the U2 curve and the U3 curve. तो जैसे अगर आपको याद हो हमने किया था XZ plane के बीच में जो area है, there y is constant. So this is the area between the U2 curve and U3 curve. So on this curve, U will be constant. So U1 is some constant C1. Is it fine, बच्चे? Is it fine, बच्चे?
Yes, ma'am.
Similarly, if I'll go to this down, if I'll go to this region, so this region is between the U1 curve and U2 curve. So on this curve, U3 will be constant. And similarly, on this side, U2 will be constant, right? And अगर मैं बात करूं इनकी intersections की, इन सारे surfaces की intersection की, right? So if I talk about the intersections of these surfaces, so we are just trying to understand this geometrically. So ये हमारी U3 curve है और ये हमारी U3 U2 curve है. So this is U3 U2 surface and this is my U1 U2 surface. So obviously it will intersect on this blue line. It will intersect on this blue line. So this will intersect on this blue line. So this blue line, and this blue line is nothing but what? This is U2 curve, and we know on U2 curve, U1 and U3, they will be constant. U1 and U3, they will be some constant. I'll not say they will be zero. I'll say they will be constant. Is it fine, bache, all of you? Is it clear, bache?
Yes, ma'am.
Geometrically हमारे पास पहले x एक्सिस थी, y एक्सिस थी, z एक्सिस थी और हमने इस सिस्टम को एक न्यू कर्विलिनियर कोऑर्डिनेट सिस्टम में चेंज कर दिया. So this is geometrically here. Now the second thing which comes into our mind is that what about the orthogonality? What about the orthogonal? What about that the curves they should be perpendicular? और हमें पता है जब भी किसी curve के along हमें perpendicular की बात करनी होती है, we talk about the tangents. So tangent is what? Any curve which touches the line, and then any line which is perpendicular to the tangent is nothing but the normal. So when I'm saying that these three curves they should be orthogonal, so actually इस point P पे जब मैं tangent बनाऊं along the three directions, so suppose Q1 is the tangent along the U1 curve, Q2 is along the tangent along the U2 curve, and Q3 is the tangent along the U3 curve. Then for the orthogonal system, these three tangents they should be perpendicular to each other. Is it clear? Is it fine, bache, all of you? So we draw the tangents at the point P in the direction of U1 curve. Say the tangent is PQ1. Then the tangent along the U2 curve is PQ2 and tangent along the U3 curve is PQ3. And if these tangents, they are mutually perpendicular, then the system is known as orthogonal curvilinear coordinates. Is it fine? Right. So now what we will try to do, we will try to look out for the condition for this orthogonality, right? We will try to look out the condition for the orthogonal system, right? So this condition is very simple. You see, हमारे पास क्या था in the curvilinear coordinate system? We have U1 is some function of XYZ, U2 is some function of XYZ, U3 is some function of XYZ. Similarly, if I want to transform, so x is psi1 of u1 u2 to u3, y is psi2 of u1 u2 u3, z is psi3 of u1 u2 u3, right? Now let us take the position vector r of any point x y z. अगर आपको कहीं पे r वेक्टर दिखता है तो r वेक्टर is nothing but the same, xi cap plus yj cap plus zk cap. So we know r is what? Xi cap plus yj cap plus zk cap. Right? If I want to go to the new system, so x is changed to u1, u2, u3 using this function. This is psi1, u1, u2, u3 I cap, psi2, u1, u2, u3 j cap, and psi3, u1, u2, u3 k cap. Right? So how will r vector change? So r vector is some new factor which is in terms of u1, u2, u3. So r vector is some new vector f vector which is in terms of u1, u2, u3. Is it fine? Is it fine?
Yes, ma'am.
Right? So now we are actually moving towards the tangent. अब हमें पता है u1 अगर मुझे, so this was my u1 curve, this was my u1 curve, so this u1 curve. So हमें पता है अगर मुझे tangent vector लेना होता है along u1, so tangent vector along u1 is something, right? उस position vector का मैं derivative ले लूं along u1. Is it fine बच्चे? अगर मैं पोजीशन वेक्टर का डेरिवेटिव ले लूं along u1, so I will get the position, I'll get the tangent vector, because tangent vector is parallel to the derivative vector, right? So you see, so now similarly अगर मुझे tangent vector लेना है along the u2 direction, so you will have del r by del u2, and similarly if I have to take the tangent vector along the u3 direction, so that is nothing but del r by del u3. and अगर मैं चाहती हूँ कि ये मेरा सिस्टम ऑर्थोगोनल सिस्टम हो, तो हमें पता है ऑर्थोगोनल के लिए क्या होता है, अगर कोई दो वेक्टर्स ऑर्थोगोनल हैं या परपेंडिकुलर हैं तो उनका डॉट प्रोडक्ट शुड बी जीरो. इज इट फाइन? सो व्हाट यू हैव, del r by del u1 dot del r by del u2 should be 0, del r by del u2 dot del r by del u3 should be 0, and del r by del u3 into dot del r by del u1 is equal to 0. So this is the condition for orthogonality. But is it fine?
Yes, ma'am.
Right, this one I missed. So you see हमारे पास r was some function of, so you just understand this. अभी इसमें कुछ ऐसा कुछ नहीं है तो तुम्हें याद रखना है, but yes, as a mathematician we should be able to visualize this, right? We should be able to absorb this. So this is u1, u2, u3. So अगर मैं आपसे पूछूं what will be r along the u2 curve, तो हमें पता है u2 curve पे u1 और u3 constant होते हैं. So this is some constant u2 and this is some constant c3. So this is how the position vector will become along the u2 curve. और हमें पता है अगर हमें tangent vector निकालना है तो tangent vector के लिए अब मैं इसका डेरिवेटिव कर दूंगी along u2, so I'll get del r by del u2. अगर मैं डेरिवेटिव कर दूंगी with respect to u1, I'll get the tangent along the u1. Is it fine? अब इसी tangent vector को अगर मुझे यूनिट वेक्टर, अब जब भी हम डायरेक्शन की बात करते हैं तो हम यूनिट की बात करते हैं. Similarly we talk about unit tangent vector, right? तो अगर मुझे इसी वेक्टर को यूनिट वेक्टर बनाना है तो मैं क्या करूंगी, इसी वेक्टर को अगर मुझे यूनिट वेक्टर बनाना है तो हम क्या करेंगे, किसी वेक्टर को जब हमें यूनिट वेक्टर बनाना होता है तो हम क्या करते हैं बेटा,
वेक्टर को मैग्नीट्यूड से डिवाइड कर देते हैं.
del r by del u1, अगर मैं उसको इसके मैग्नीट्यूड से डिवाइड कर दूं, so this is nothing but the unit tangent vector in the direction of u1. Is it fine? Similarly, del r by del u2 divided by magnitude of del r by del u2 is unit tangent vector along the magnitude of along u2. Similarly, del r by del u3 over magnitude of del r by del u3 is unit tangent vector along u3. अब मेरी बात ध्यान से सुनो बेटा. We have I j k, right? बार बार मैं उधर क्यों जाती हूँ, बिकॉज उसको हम रिलेट कर पाते हैं. सो दिस इज x एक्सिस, y एक्सिस, z एक्सिस. तो अगर आप देखो I वेक्टर इज अलोंग द x एक्सिस. सो जब मैं अलोंग द x एक्सिस की बात कर रही हूँ तो इफ यू सी इट इज नथिंग बट इन द डायरेक्शन ऑफ द टेंजेंट टू दिस वेक्टर. अगर मैं y एक्सिस के अलोंग वेक्टर की बात कर रही हूँ तो दैट इज नथिंग बट द टेंजेंट वेक्टर, सॉर्ट ऑफ टेंजेंट वेक्टर, राइट? दिस इज टेंजेंट वेक्टर, राइट? सो दिस इज द रीजन हमने डेरिवेटिव लिया. एंड I कैप इज नथिंग बट द यूनिट वेक्टर. तो अब टेंजेंट वेक्टर तो हमने निकाल लिया del r by del u1. अब इसको यूनिट बनाने के लिए हमने इसको मैग्नीट्यूड से डिवाइड कर दिया. तो ये जो फाइनल यूनिट वेक्टर आया इसको हम नाम दे देते हैं कर्वीलिनियर कोऑर्डिनेट्स में e1 कैप. इज इट फाइन? सो e1 कैप का वही रोल है जो I कैप का रोल था. सिमिलरली e2 कैप का वही रोल है जो j कैप का रोल था. e3 कैप का वही रोल है जो k कैप का रोल था. So this is e1 cap is a unit vector along u1 curve. E2 cap is a unit vector along U2 curve. जैसे हम किसी भी पोजीशन वेक्टर R को लिखते थे xi cap plus yj cap plus zk cap, तो अगर हम कर्विलिनियर कोऑर्डिनेट्स में आएंगे तो हम क्या लिखेंगे, समथिंग इनटू E1 cap plus something into E2 cap plus something into E3 cap. Is it clear बच्चे? बच्चे क्लियर है?
मैम
Right, so E1 cap is nothing but the unit vector along the direction of U1, right? और एक और notation हमने याद रखनी है, that is like this magnitude del R by del U1, इसके magnitude को हम H1 बोल देते हैं. So you see this vector del R by del U1 is nothing but its magnitude into direction. So magnitude को हमने नाम दे दिया H1. So this is H1 E1 cap. Similarly, del R by del U2 will be H2 E2 cap, and similarly del R by del U3 is H3 E3 cap. यहाँ तक clear है बेटा? Girls clear है? कोई doubt यहाँ तक?
yes मैम